Hello, this video is on significant digits. These are sometimes abbreviated and called Sig Digs. That is what I like to call them. But you will often hear other people refer to them as significant figures or sig figs. And those are the same thing. Don't let that confuse you. So this is a system used in science to indicate the exactness of a measurement. We're going to talk about, when we look at a number, how many sig digs it has, how many digits are significant in it. And we're referring to kind of how well we know this number, how confident we feel in the accuracy of this number. There are two ways to go about determining how many sig digs there are in a number. So in this video, I'm going to go through kind of 5 rules that are commonly taught. But then there's also another way to look at it called the Atlantic Pacific Rule. And you'll see that in your notes packet. And there is a video for that right below this video in Moodle. So when you're done with this one, please watch the Atlantic Pacific Rule. And then in class, we'll discuss them both and we'll determine kind of which way makes the most sense to you. So significant digits. First, the 5 rules for determining how many sig digs your number has. The first rule is that non-zeros are always significant. So meaning we're looking at numbers, and if there is not a zero, if the number is not 0, it is significant. So if you have 12.75, we've got the numbers 1, 2, 7, and 5. No zeros at all. So this number has 4 significant digits. All right, so another one, if we had 863, this has no zeros, so we've got 8, 6, and 3. This number would have 3 sig digs, and lots of times I just write SD for sig digs. All right, so what about when we start looking at zeros? Okay, so zeros between non-zeros are significant, or zeros between any sort of sig dig are always significant. So this could be something like, let's see, 10.32. So I've got the 1, the 3, the 2 that are all significant. And I've got this 0 in between. As long as it's between 2 sig digs, it is also significant. So this number would have 4 sig digs. Now you could have a number like 1,002. As long as you have sig digs on one end and the other end, everything in between will also be significant. So it doesn't matter how many zeros are in there, this one also has 4 significant digits. So depending on how many, doesn't matter how many zeros there are in between, or even if it has a decimal like the first number I wrote, this has numbers on the ends that are significant. We'll count everything in between. All right, so the next rule is zeros used merely as placeholders are not significant. So this would be a number with what we call leading zeros. So something like 0.00035. So this 3 and this 5, to show that they're in those places, you need these zeros before it to show that there's no tenths, no hundredths, no thousands, and so on. So this one only has 2 significant digits. Those zeros are all what we call placeholders. And it doesn't matter how many there are. It could just be 1. It could be 0.05. That would be just 1 sig dig. Now, quick side note, remember that if you have like 1.05, you have, based on rule number 2, sig digs on either end, so the one in the middle would count. So that would be 3 sig digs. So that's still based on this rule. All right, so the next rule is zeros at the end of a number and to the right of a decimal are significant. So let's make sure we understand what that is. At the end of a number means all the way to the right. But if it's also, and it's got to be both, and to the right of a decimal. So something like 5.70. So this 0 right here, this 0 I'm going to do in green, is at the end. Right? It's all the way to the right of the number, but it's also to the right of this decimal. So this one would have 3 sig digs. Now you could have multiple zeros there. You could have 5.000. Now you've got zeros at the end, 0 at the end. Okay, this guy right here, and it's to the right of that decimal. So that is significant. And we know the 5 is. So based on rule number 2, that also makes these significant. So this would have 4 sig digs. Now make sure you're writing down all these examples. I should have said that earlier, but it will be helpful when you go back and look at your notes later. All right, so the last part is zeros at the end of a number and to the left of the decimal may or may not be significant. So here's where we're going to want to use our scientific notation or a decimal point to clarify. So let me explain more what I mean. If we have, let's say, 2,500. All right, so these zeros are at the end. However, they are not to the right of a decimal like rule number 4 says. We know that when there's no decimal written down, like right now it's not present, all right, we know that it's actually right here. Okay, so what we're looking at is, are these zeros significant or not? So it's unsure when we write it this way, but if I use scientific notation, I can make it more clear. So let's say our number actually has 2 sig digs. So that's where I would write 2.5, which has 2 sig digs in it, times 10, and in scientific notation, I would be moving, right, my decimal is here, 1, 2, 3 spots, so 10 to the third would be my number. So this would have 2 sig digs. So it's the same number in 2 sig digs, if that's all I know, just to be clear. If this actually had 3 sig digs, I could also write that. That would be 2.50 times 10 to the third. Because we've got the 2, the 5, and that 0 at the end and to the right is significant. So this one would have 3 sig digs. Now, what if I wanted to make it 4 sig digs? Okay, there are actually 2 different ways to do this. So you could do, 2.500 times 10 to the third. Oops, times 10 to the third. That is one way to do it. The other way to do it would be to write 2,500 and then put a decimal at the end. You can do that, and that decimal makes those zeros significant. It's saying we know those to be accurate with nothing else. So those are the 5 rules to determining significant digits. Please now watch the Atlantic Pacific rule and write those notes in your notes packet, and then we'll discuss them both in class.